All right, so any questions?
My program's running, it's taking the info out and typing it in. Do I have to do Control D for it to print the list, or am I missing something?
So yeah, so end the file, you hit enter, and then at the beginning of a new line, hit Control D.
Okay.
That tells the scanner that there's nothing left, and so your has next will come back false.
Okay.
And then it'll go ahead and print everything out.
Just want to make sure.
Yeah, no, that's exactly what it should do. All right, well, we had a rectangle and an oval drawing yesterday. Alright, so we run this and we had our rectangle and we had a green oval because in the afternoon class we added the set color method. So g.setColor, color.green, and then when we draw the oval it comes out in green. And not a lot of surprises here. So we make a red rectangle and a green oval if we want. So again, this is a question of just getting to know your classes. So the color class, among other things, comes with a bunch of static fields called black, blue, cyan, dark gray, gray, green, etc., etc. Right, since they're static, you can access these by saying color, the name of the class, uppercase C, dot, the name of the field, and that gives you your color, or you can construct it using values of red, green, and blue, like we talked about yesterday. So, assuming you've gotten this far and you've gotten this to work, and nobody tried getting this to work yesterday on their own? It really helps if you play along at home, because we're going to keep building on stuff. And in particular, if there's something flaky with the version that people are getting for Windows or something like that, we want to find that out soon because we might switch gears to a different IDE. So any feedback would be great on success or failures with this. All right, so remember we overrode the paint method because the paint method is the thing that causes painting to happen. And let's try to tie this button into our code. What I'd like to do is when you click the button, I'd like to move this rectangle around. Okay, so right now, where's the rectangle being drawn? It's being drawn at 40, 40. I'd like to change those coordinates when you click the button so that it draws this rectangle at a different location. And if we go into the button, if we right click and say create listener, and we add an action listener for action performed, we can put code right here that will fire whenever the button is clicked. And we'd be tempted normally to say, okay, well, at this point, let's draw our rectangle. Let's keep track of x, y locations, and let's increment them. And let's draw our rectangle at that new position. So I'm going to do the following. So I'm going to keep track of what my last x and y positions are. And when we press the button, I'm going to increment my x position and increment my y position. And then I want to draw the rectangle at last x, last y. So every time you click, last x, last y get incremented by 10, draw the rectangle at that new location. But how do we draw a rectangle here? Because to draw a rectangle, we got to say g dot fill rectangle, and we need this graphics object g. And we cannot do that at this point in our code. And there's two main issues with trying to draw right here. The first is we just don't have the graphics object that we need. Right? We need the graphics object that will eventually be passed as an argument to Paint. But at this point inside our button handler, we don't have access to that graphics object. But there's a more fundamental reason why we don't want to draw the rectangle at this point in our code, which is in general you only want one thing doing the drawing. This would be like sharing a whiteboard with someone. So somebody is working on the whiteboard and someone clicks your button and you run into the room and you start drawing on the whiteboard too. Right? And if you don't coordinate with somebody else who's using the same resource, right, you can get all kinds of weird results. So we want to leave the Paint method to be the thing that's doing the drawing. But to continue that analogy, somebody's working on the whiteboard and you want to draw a rectangle, what you could do is come over to them and say, hey, can you draw a rectangle in the middle for me? And then at some point when they're at a convenient stopping point, they'll draw the rectangle and they'll go back to what they were doing. That's basically what we're going to do here. So first thing we need to do is we need to somehow tell this Paint method what the value of last x, last y is. So we're going to write a bunch of code. The My Panel is called My Panel 1. So let's tell the My Panel 1 object where to draw. So I'm going to call a method in My Panel 1 called setCorner, which is going to set the lower left corner, and I'm going to pass it the coordinates last x and last y. And there is no setCorner in My Panel 1. We have to write that. That's why it's red right now. So I'm going to take the arguments that are passed to setCorner, I'm going to save them in some class variables I'm going to call lower left x and lower left y. So I'm going to declare these. As private variables. Okay, so what's the setup now? When I call setCorner something comma something, it'll set LLX, LLY equal to those things that I passed. And now in my fill rectangle method, instead of hardwiring 4040, I'm going to use LLX and LLY. So if we run this, something will sort of happen. So the button's clicking, the rectangle's not moving. Okay, it's still right next to the button, slightly down and to the right, but watch this. And if I do anything to the window, it draws the rectangle. So the next thing we want to be aware of is in my button handler, what happens when the button's pressed? I print out a message, I update my local variables last x and last y, I call the setCorner method to save last x and last y, which is doing nothing other than copying these into these local variables. But I don't call paint, right? And until paint gets called, the fact that I'm going to draw the rectangle at a different set of coordinates has no effect. So something's got to call paint. And when we're running this, if you resize the window, paint gets called by swing. And if I cover up the window and then expose it, well, that didn't draw it. Whoa. There we go. So how do we make this happen? Well, we could try calling paint from our button handler. But remember, to call paint, we have to pass a graphics object, and we don't have a graphics object. And something else might be already painting, and if we call paint, we're going to have two things painting at the same time again. Right? We got to work within the framework of swing. We've got to play nicely with everything else happening in the system. So there's a method just for this, and it's called Repaint. It takes no arguments. And all of these components have a repaint method. And repaint gets inherited from component. And if you look at the documentation for repaint, adds a specified region to the dirty region list. That's kind of cool. The component will be repainted after all of the currently pending events have been dispatched. So you're making a request to swing, and you're saying, hey, this component needs to be redrawn. And I understand you may not be able to do it right now because you may be doing other things, but when you have a chance, please redraw this component for me. And you're going to call repaint, you're going to come back from the call to repaint, and nothing may have changed yet. But there's another thread running in the background, right, which is handling all of the events, picking up mouse clicks, and among other things, it's painting the components. And it knows that you've asked for it to repaint the J panel in this case, and so when it has time, it will do that. So we're going to update last X, last Y, and then we're going to say my panel one.repaint. And so now if we do this, click the button, rectangle moves. So why did it go underneath the oval instead of on top?
The oval's drawn after the right.
Because the oval's drawn after. Draw the oval first. And the rectangle goes on top. So drawing order always matters. Alright, so this is a basic mechanism we'll use again and again and again to do any drawing and swing. We create our own version of, say, a J panel, which is an extension. I should just go ahead and write these down. So painting and swing. If you want to draw on a J panel, let's extend the J panel. Which I've just been calling a my panel, but you can call it whatever you want. Overwrite the paint method. I think we did this in the afternoon class, but not in here. I added a statement in here which says super.paint. Okay, remember this is a keyword which refers to myself. Super is a keyword which refers to the thing which I extended. Since my panel is an extension of JPanel, super refers to basically the JPanel class. And so JPanel has a paint method in it. My panel has a different paint method, which we're just defining right here. But I can still get to the original paint method by saying super dot name of the method. So when I say super.paintG, I'm calling the original JPanel's paint method, and then I'm doing my own stuff, drawing a rectangle, drawing an oval. And I don't know if I can make it misbehave, but if we don't call the super classes paint method, this is one of these things that may work, or it may just do strange things, right, like this. Now that's kind of cool, right, but it's not what we meant. And it looks cool, but if I resize the window, right, that goes away. Right, so what's happening, we're just doing those things in our paint method, draw a rectangle, draw an oval. And since we're not calling the super classes paint method, one of the things that thing's supposed to do is clear the background, right, make it all one color, and then you go ahead and you start drawing. Without that, we get this persistence, which might be cool, but not something to rely on, because depending on what you do, that may go away. So we generally want to call the super classes paint method. Okay, so override paint, include super.paintG, and then we just call repaint to request that paint gets called. So questions? Alright, let's play with this further then. How many people here have a laptop in front of them with IntelliJ on it? We might try some of this in some group exercises later this week. Okay, let's make a new class. Let's make my panel. Extend this J panel. And let's drop a J panel in here. So I'll go to non-palette component, come in here, ask for my panel, create a binding. There's my panel. Going to set it to fill. So we're good to go. So let's add a MouseListener. So we'll do a MouseListener. We will say mouse moved. And so this method gets called whenever the mouse changes position inside the J panel. And how do we find the coordinates of the mouse? Do you remember? Yeah, good. So we're past a mouse event. So mouse event dot and get X. And get Y. So let's run this. And we have no panel. Let's see. Where did I put my listener? Anyone see what's going wrong? Let me change the background. Let's see if our panel's actually there. Nope. Alright, I'm going to figure this out later then. Because I'm doing something silly, I suspect. Let me try one more thing. Oh, okay. So we can pick up clicks. Okay. I gotta mess with this later because I don't know why it's not picking up mouse motion. And we've had this working before. But I'll mess around with it later. Alright, so let's talk about our calculator that we were making the other day. So we started off, we had a calculator with two buttons, right? And we could hit numbers in and it was displaying our number, and it was also displaying the number in binary next to it. And suppose we wanted to extend that to, you know, a plain old decimal calculator. So 10-digit buttons. And we want to be able to hit numbers and have the number appear in the display the way it does on a usual calculator. So what kinds of things would you need to do when a button is pressed? Right, each button we're going to add an action listener to. And that action listener, that code is going to get called when the button is pressed. So what should be inside the action listener for, say, the 7 button?
Some means of printing it to a string, and also recording that number and appending it to a string.
Okay, so we want to print it to the screen, and we want to remember that by appending it to a string. And we could probably do both of those in one fell swoop. If we have something like a label, let's call it JLabel, and that could initially be just an empty string. So when you hit a 7, right, append 7 to the label. So let's look at a JLabel, because JLabels are pretty lightweight components. So JLabel has a method called getText and a method called setText. And a label is just a box that displays something. You can't type in it, it doesn't have a whole lot of embellishment, but it's a way to put a piece of information on your display. And it has a set text method. It takes a string and it basically displays the value of that string in the label. So when you hit a button, right, we could get the current text from the label. We could append the button code that you just pressed and then use set text to display that in the label. And then at any point when we want to know what the current number is, we can just say get text from that label, right? Or we could have a local string that we use to keep a local copy of it. Either way. Alright, so you start hitting buttons. You hit a 2 and a 3 and a 4, and you see the number 234 on your display. So we're going to have 0 through 9. So what happens when you hit the plus button? What would we like to do? What happens when you hit the plus button on a regular calculator?
It allows for extra input, either by clearing the screen or appending it on the end.
Okay.
Plus symbol.
Okay.
Sometimes also displays the result. So if you hit, say, 2 plus 3 plus, it says 5 on the screen.
Okay, so it could act like hitting the equals button, right? Could also act like hitting the equals button. So plain old calculator. This is always risky because you never know who's going to text. So I'm going to hit 23 and I hit plus, and I got a little fancy plus symbol over there, but the 23 is still on the display, right? But if I hit another digit, it doesn't become 234, it becomes a 4. So when you hit the plus, it somehow makes note of the fact that you're ready to start entering a second number. So we'd probably like to save the first number, and we'd like to do something like set a flag. So next button starts a new number. And if we've already done this twice, then it should also act like an equals sign. Alright, and what happens when you hit the equals sign? Yeah, I did 23 plus 4, and now I hit equals, and there's 27. So what is the result that it's going to display? The result of what?
The first number plus the second number.
Okay, so calculate the first number plus whatever the current number was. Display result. But is it always the first number plus the current number? Could be first number minus the current number. Could be first number times the current number. So this plus is not always what exactly we want to do, right? It's a plus because we hit a plus before we started typing in the second number. So we got to remember that a plus was hit. So set flag to remember that you hit a plus sign. Okay, so what are we seeing here? We're seeing a state machine, right? When you hit the equals sign, a lot of different things can happen. You might do an addition, you might do a multiplication, you might do nothing at all. If I turn on my calculator and I hit equals sign, it doesn't do anything. If I type 234 and I hit equals sign, it doesn't do anything. But maybe it does. So 234 equals, and now if I type a 5, I've got a new number. And if I hit equals, I've just got that number. Right? So the behavior of this depends on what's happened in the past. Right? That's the notion of state. So we need to know what different states this machine can be in. And once we have a clear understanding of that, it's pretty easy to write code. So what are some of the states that a calculator sits in? So I'll start you off. Alright, so state 1 is when you just start. So you just powered on the calculator, or you just began running your calculator program. What are some other states? Let's just brainstorm. Input. Inputting a number. So we'd like to know if we're typing in a number.
Inputting an operator.
Say again?
Inputting an operator.
Okay, inputting an operator. And let's just go plus, minus, times, divide. Inputting a second number.
Clear. Is that a state? It's like going back to just started, but
So what happens when you hit the clear button?
So your current number?
Remove your current number and set your state equal to beginning.
Yeah.
it's also the clear entry.
So yeah, let's just do an all clear for now. Keep it simpler. So when you hit all clear, it basically goes back to the just started state, right? So zero out whatever numbers you have, whatever variables you have, flags, and go back to state 1. So that'll bring us back there. What other states?
AC, so it's gonna say the values.
When you hit what?
AC.
AC just wipes everything out, goes back to the beginning.
Basically, not the calculator when I get the result and I hit the S, it's gonna say the previous result and do calculate another one.
Okay, so it saves old results?
Yeah, yeah.
Okay, we're not gonna get that fancy yet. We'll go old school here. So you can do one calculation and you can keep doing calculations on it, but if you say all clear, basically goes back to a power up stage. Yeah.
So AC would just do initialization, and then clear would just reset your current register that you're putting in.
Yeah. I'm not going to worry about a clear button yet.
We need like a display result state, right? So after you've done the calculation.
Yeah, so when the equals sign has been pressed, that's a different state. Right? Because you're getting ready to input a first number, but you still have stuff on the display. And you need to clear that out the first time that you press a button and make that button an input. And you also need to remember your current result in case you do, 2 plus 3 plus 5, that kind of thing.
So if we're in our equal state and then we input an operator, that becomes our first number.
Yeah, yeah. So what about inputting a number? Is that a single state? So inputting a number, you're typing digit buttons. Is the behavior of that dependent on anything other than the button that you just pressed?
Well, we had the first character things from yesterday.
Mm-hmm. All right, so number input. So we could be waiting for first button. And the first button that you press, that becomes the first number that you see on the display. So you might have something on the display, and I'm in my state where I want to input a number, but the first button that I press should clear out what's in the display, right, and set my number equal to just what I typed. And if I have a 0 on my display and I hit 0, I should not display multiple zeros. But if I have a 1 on my display and I hit 0, I should display multiple zeros. So waiting for first button, we need another state. Might not have to be a separate state, but where we're basically ignoring the 0 button.
If your entry register's full.
Yeah, so entry register full. Because if you type too many buttons, you don't want to keep making your string longer and longer and longer. You want to stop at some point where it's not going to convert to an integer. So maybe every time that we add to our string, we'll make a try-catch loop and block, and we'll try to convert to an integer. And if there's an error, then we won't add that thing that we were going to add to the string. What else weird can happen in input?
Decimal place.
Decimal place. So if we hit a decimal point, then we just need to sort of add a decimal point to our string, unless we've already done a decimal point, in which case we should ignore it. So add to string, unless already in the string. So that's basically a bifurcation of our states again. We have a state where we have not yet hit a decimal point, or a state where we have hit a decimal point. And we don't necessarily need separate states for each of these things. We could have a flag, right? Or when you hit a decimal point, we could just check wherever we're saving this string and see, is there a period in there? And if there is, the decimal point becomes a no-op. If there isn't, we go ahead and add it. But it's something that's going to affect what happens when the decimal point gets hit.
A sign switcher, like positive or negative.
Yeah, so what about the minus button? So if I do 5 minus 3, it gives me 5 minus 3 is 2. But if I'm waiting to enter a number and the first thing I press is a minus sign, then I'm actually entering a negative number. So if it's the first button that I press, other than maybe a bunch of zeros, actually without zeros, so if this is the first button, then our number is negative. If it's not the first button, then it's a subtract operation. By the way, is everybody signed in? And so we ignore the leading zeros, but actually if we type a 0 and then we type a minus, that's actually saying, let's do 0 minus 5. So we don't always ignore zeros. We need to note if you've pressed at least one zero so that we know whether this minus sign is part of a negative number or a subtraction operation.
Does it end up the same way?
It'll end up the same way, yeah. Usually. Depends what you're doing in your code, though.
Well,
So-
aren't there oftentimes separate buttons for minus and for negative?
Yeah, so there can be like a plus minus button also.
So if you do minus without doing anything, it should just give you like so if you do like -6 right now, you should get -6.
Yeah. So -6 times 3. So making the graphical part of a calculator is not the biggest challenge, right? The challenge is sort of figuring out the state behavior of your program. All right, so we'll play with this more tomorrow, and I'll figure out why mouse events weren't working in that J panel. And try some of the stuff in IntelliJ, and post some notes. Let us know if this is working or not.